Hey AP Chemistry, so I got a couple of requests for videos, so I'm going to start with question number 56 from your chapter 1 exercises. So question 56 is just to make sure that you're good for scientific notation and making sure you know how to convert between units. So on page 17 in your textbook, and you all have textbooks now, there are some common multipliers, and I just wrote a couple of them just to show you different ones. So 10 to the minus third grams is 1 milligrams. Same thing as saying 10 to the minus third meters is 1 millimeter. These two have the same multiplier. They're just different units, like grams and meters. They're different measurements. 10 to the minus 9 grams is a nanogram. 10 to the minus 6 grams is a microgram. 10 to the 6th gram is a megagram. 10 to the 12th gram is what we call a teragram. So just a couple of examples. So in this question, I wanted you to use prefix multipliers to turn these scientific notations into non-scientific notation and regular numbers. So in the first one, I'm going to kind of go back and forth and show you how you could move the decimal place. So if I have 38.8 times 10 to the 5th gram, I could actually move the decimal point in different ways, and it'll change my exponent. If I move the decimal point to the right by 1, right? If I put it here, this makes this number go down by 1. So this could be 388 times 10 to the 4th gram. Or I could move the decimal point once to the left. If I move it to the left, this goes up by 1. So I could do 3.88 times 10 to the 6th gram. Right? So I'm just showing you if I moved it to the right, 1, my exponent goes down. If I move it to the left 1, my exponent goes up. If I'm making this number smaller, I'm making my power of 10 bigger. If you need more help, and I made a note, scientific notation part A on page A1, also in appendix 1 it's called, letter A talks to you all about scientific notation, so if you wanted to check that out. Anyways, so now what it wanted to do is turn this number into a common multiplier. I actually have something that's 10 to the 6th. 10 to the 6 grams is 1 megagram. If I want to show that math, I could do 3.88 times 10 to the 6 grams times 1 megagram over 10 to the 6 grams. 10 to the 6 is going to cancel out with 10 to the 6. Grams is going to cancel out with grams. I'm going to get 3.88 megagrams. That's one way of doing this. If I wanted to do it any other way, and this is just another possible answer, and then later on in the other questions, I'll just do them quickly. I could do 388 if I wanted to, whatever number I converted. 388 times 10 to the 4th gram. And if I wanted to, I could multiply and get maybe a milligram. I know that 1 milligram is 10 to the minus 3rd gram. That's what's given to me up here. If I want to do this math and simplify, right, I'm doing dimensional analysis here, so I could do 38.8 times 10 raised to the 4th times 1 divided by 10 raised to the minus 3rd. I'll get a huge number, which probably wouldn't even make sense to use for megagrams, but I'll have 388 followed by 1, 2, 3, 4, 5, 6 zeros. 3, 4, 5, 6 zeros. Milligrams. Okay? Now, which of these numbers might be easier to use? And that's what the question's really asking. Use a prefix multiplier to express each measurement without exponents. Which of these would probably be better without exponents? Probably the 3.88 megagrams. There's not all these freaking zeros. So whenever you're trying to figure out which multiplier, you want to probably get it to the smallest number, or the one that I could express without that many zeros. So I'd probably say the best choice of answer would probably be our megagram. Let's look at a different one. I'll do 55.2 times 10 to the minus 10th. I will move the decimal to the left one, right? If I do that, I get 5.52 times 10 to the minus 9th second. I already wrote something over here. 10 to the minus 9th gram is equal to 1 nanogram. I could also say 10 to the minus 9th second is equal to 1 nanosecond. It's the same thing. So if I wanted to, I could say multiply by 1 nanosecond over 10 to the minus 9th second. And I'm going to get 5.52 nanoseconds. right? 10 to the minus ninth and second, 10 to the minus ninth and seconds are going to cancel out. I'm going to be left with nanoseconds. Now, do you have to show this math? No. If you could just recognize that 10 to the minus ninth is a multiplier, you're good to go. I'm going to do that in the next one, right? And remember, if I move to the left, I make my exponent go up by 1 or increase by 1. And remember on our number line, 0, let's say it was -2, -4, -6, -8, -10, and -9 is here. Going to the right increases in numbers. Or remember, if I'm becoming less negative or more positive, I go to the right. So -9 is larger than -10, just like a little aside. All right. Letter C, I'll just do it simply, 2.34 times 10 to the 12th. Remember, I go to the left one. I increase that by 1. All right, 10 to the 12th meter. And I already see up here, 10 to the 12th meter is 1 terameter. So it's the same thing as saying 2.34 terameters, right? And this terameter means 10 to the 12th meters. That's where I'm simplifying it. I'll do the last one, 87.9 times 10 to the minus 8th. 10 to the minus 7th. I'm going to see which one can help me get something as close to any of these multipliers. I have a 10 to the minus 6th, and I have a 10 to the minus 9th. If I want to go 10 to the minus 6, I could go to the left one, right? That's going to increase by 1. And remember, right, and I know I'm being a little bit crazy here, but -1, -2, -3, -4, -5, -6, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3. If I want to increase by 1, I go to the right with negatives. So increasing -7 by 1, if I add +1 to -7, I get -6. So I'll move my decimal point to the left, and this increases by 1. 8.79 times 10 to the minus 6 liter. And then I already know 10 to the minus 6 something equals micro. So 10 to the minus 6 grams is equal to a microgram. 10 to the minus 6 liter is equal to a microliter. So I could change this easily to being 8.79 microliters. Okay, you will have to know how to do scientific notation and converting between the two. For the first two, I showed you math. For the last two, I showed you how you could just assume that multiplier is the same as that unit. Alrighty, so hopefully this video was helpful. This is just for question number 56 from your chapter 1 exercises.